Hello everyone, myself Nishan and I am here to explain my code for SID 210 Embedded System Development. Let's see. This is an Arduino code is designed to connect your Arduino board to an MQTT, means message queuing remote transport. It is a broker over Wi-Fi, receives messages from a specified topic on the broker and control LEDs based on received messages. Here is a function overview of the code in simpler terms. It includes the necessary libraries for MQTT and Wi-Fi communication depending on the type of Arduino board you are using. Here we are using Arduino Nano. Different tags required for different libraries. It sets the Wi-Fi network credential, SSID and passwords. Here you can see I have used my personal hotspot which has SSID as Redmi and password is 000 and it setups a variable named light. Here you can see int light equals to 2 and assign its value 2. This is probably the pin number where the LED is connected to your Arduino board. It creates a Wi-Fi client named as Wi-Fi client and an MQTT client object which is known as MQTT client object. Protocol used for communication between devices and services and process messages and channels.
Good morning everyone. This is SIT 210 Embedded System and Development Task 3.3D prepared by Mayank and Nishant. I am Mayank. So, firstly we check what we have to do in this task. For this task, we were required to establish a public survey, publish and subscribe communication between Arduino using MQTT broker in order to receive virtual waves messages. So let's talk about MQTT. So MQTT stands for Message Queuing Telemetry Transport. It's a broker. It is a broker, a central server or a service that plays a crucial role in MQTT communication protocol. Uh, MQTT is designed for lightweight, efficient, and reliable communication between various devices and applications. So, there are it is basically a piece of software that acts as intermediary or message hub in the MQTT communication architecture. It receives messages from MQTT clients, which are publishers, and routes them to other MQTT clients that are subscribers based on topics. MQTT brokers ensure that messages are delivered to the correct subscriber, allowing them for efficient and organized communication between devices and applications. So there are many benefits which this broker provides, such as it's a lightweight protocol. Also, it follows a publish subscribe model, and it helps in asynchronous communication. Also, it provides a good reliability where brokers can store and forward messages to ensure reliable delivery even if a device is temporarily offline. So it is also provides a remote monitoring and controls over Arduino boards. And also with this scalability, data aggregation and load overhead are improved, and especially it helps in message filtering. So now let's come to the code for the MQTT. Before code, let's talk about the hardware. So in hardware part, we have used two Arduinos, one for publisher and one as subscriber. In the publisher, we have used ultrasonic sensor, breadboards for the publisher module, and for the second module, we have used Arduino and LED. So basically, when the distance is below a particular threshold, the publisher sends signal through MQTT to the subscriber one to blink its LED. So now let's come to the code. So firstly, there are some libraries which we have defined, and each library has different functions. So firstly, there is Arduino MQTT client library. This library provides MQTT client functionality for Arduino. It allows the Arduino board to connect to an MQTT broker, publish messages, and subscribe to the topics, facilitating IoT and communication with other devices via MQTT. Then there are some libraries such as Wi-Fi Nina, Wi-Fi 101, ESP8266 Wi-Fi. So, and these libraries helps us to provide Wi-Fi connectivity capabilities. These libraries enable the Arduino to connect to a local Wi-Fi network, which is essential for internet-based communication and MQTT messaging. And there is also another library which is Arduino secret, that is commented out. So which act as a placeholder for user specific configuration and also store specific data. So for this task, each library serves a specific role in the code to enable Arduino board to connect with Wi-Fi and communicate with MQTT broker. So on moving further, we specified uh, two variables which stores the Wi-Fi configurations of the user, the Wi-Fi network credential. First one is SSID and second one is password. So SSID stores the name of the Wi-Fi, and pass stores the password. So later on we have defined the pin configuration for ultrasonic sensor, and that is trig pin and our echo pin. So then another two variables for storing distance measurements. Later on we have provided MQTT broker configuration, uh, including two variables that are Wi-Fi client and MQTT client objects, which are essential for Wi-Fi and MQTT communication respectively. Then MQTT. This part specifies the broker's address, that is MQTT broker configuration, where we have defined broker address and the port through which the broker will execute, and the topic for the execution of our program. So it tracks the previous time and a message was sent, and later on we have defined the pause in the previous millis, which is a variable, and the count variable for tracking the measurements. So then comes to the setup part. So in setup function, the setup function initializes serial communication for debugging purposes. It attempts to connect the specified Wi-Fi network and keeps retrying until a connection is established. The code then attempts to connect to the MQTT broker. If the connection fails, it enters an infinite loop, providing an error message. So the main loop starts. The loop function is a main program loop and performs the following tasks. So firstly, it calls the MQTT client regularly to maintain MQTT connection and handle MQTT messages. Implements a timer mechanism to take measurements, distance measurement for a defined interval, and measure distance using ultrasonic sensor by sending a pulse and calculating the time it takes for the echo to return. Then there is a condition for where which it checks the measured distance with a defined threshold that is less than 12 centimeter, and if so it sends MQTT message with distance information. And with this it also keep tracks of the number of measurements taken by incrementing the count factor defined in the code. So this was the cost for the publisher module, and